two populations, hypothesis testing for population means. So when it comes to hypothesis testing for the means, first we write our null hypothesis and alternative hypothesis. If it's the case that mu1 is equal to mu2, alternative hypothesis says mu1 is not the same as mu2. So the rejection regions are in the tails of our graph. The rejection regions are on the tails, left-hand side and also right-hand side. Whatever your alpha is, alpha divided by 2 forms your rejection regions. If it is the case that you're reading the example and it says the mu1 is larger than or equals to mu2, it means that your null hypothesis is given. So alternative hypothesis is mu1 less than mu2. It means that you have a left tail graph. The rejection region is going to be on the left-hand side. So this is the left tail graph that we have, and this is our alpha. This is the area, which is your alpha. Well, if you're reading the question and it says, well, your mu1 is less than or equals to mu2, it means that the alternative hypothesis says that mu1 is larger than mu2, or we have a right tail graph. Right tail graph. Okay, let's take a look at the graph. The rejection region is going to be on the right-hand side. The alpha is going to be on the right-hand side, this little area. So check to see if sigma 1 and sigma 2, which are the standard deviation of populations, are given or not. If they are given, it means that you are dealing with the z values. So what is alpha? Alpha is our level of significance. Level of significance, it can be 1%, 2%, 3%, 5%, 6%, 7%, 10%, small percentages. So after that, you need to find the critical values. These critical values are the dividing numbers. Dividing numbers, these values separate the rejection area from the non-rejection area. So after finding your critical values, you're going to move forward and find your standardized test statistics. The standardized test statistics is x1 bar minus x2 bar, the first sample mean minus the second sample mean, minus mu1 minus mu2 divided by square root of sigma 1 squared over n1 plus sigma 2 squared over n2. Very good. After doing that, you're going to either find the p-value, or just to use the rejection area, or use the rejection area. If p-value is less than equals to alpha, then you reject the null hypothesis. If p-value is larger than alpha, you say that I fail to reject the null hypothesis. The same as if you are dealing with your test statistics. If test statistics, if z is in the red region, red area, we reject the null hypothesis. If z is not in the red area, we say that, hey, we fail to reject the null hypothesis. This is our very first step if sigma 1 and sigma 2 or the standard deviation of populations are given, you're going to use your z-test statistic. Now, suppose you start writing null hypothesis, alternative hypothesis, and you get to the situation, to the step where there are no standard deviation of populations. If the standard deviations of populations are not given to us, we are not allowed to use our z. So in this case, we're going to move forward and use our t. But for t, we should be just careful. We have scenarios about our using t and finding the standard error. So in this case, standard deviation of populations are not given. If they are not given, we have to use S1 and S2, which are the standard deviations of the samples. Samples standard deviations, SDS standard deviations. So what is the scenario here? What's the case here? So you're going to deal with different cases. If from past studies, if in the project that you're dealing with and you get the information about the variances of populations, if the person who gave you the project says from past studies, we know that variances are equal to each other. It means that the populations have same variability. Then the standardized test statistic T becomes x1 bar minus x2 bar minus mu1 minus mu2 divided by, now we are using the pooled estimate of standard deviation, which has this ugly looking formula, n1 minus 1 times s1 squared plus n2 minus 1 s2 squared divided by n1 plus n2 minus 2, and the degrees of freedom for t that you're going to use is the same as the denominator inside the radical, n1 plus n2 minus 2. However, if from past studies, the information given to you says that, hey, variances of the populations are not equal to each other, the t follows a different formula. T becomes x1 bar minus x2 bar divided by, this is minus mu1 minus mu2 divided by square root of, well, here you have now s1 squared divided by n1 plus s2 squared divided by n2. And the degrees of freedom is going to be the minimum of n1 minus 1 and n2 minus 1. So after finding your test statistics, you're going to follow the same formula. You can either find the p-value. If p-value is less than equals to alpha, we reject the null hypothesis. Or if your t, the standardized test statistic, is inside the rejection area, you reject the null hypothesis. If t is in the red area, we reject the null hypothesis. You have two approaches when it comes to hypothesis testing. You can either use your p-value, check to see if p-value is less than equals to alpha and reject the null hypothesis, or check to see if the number that you created, either using the pooled standard deviation or not, is inside the rejection region or not. Well, now what if the question is asking about proportions, not the means? Let's see what we have. Well, okay, let me erase this. And we are dealing with proportions. instead of the mean. So we have to change our null hypothesis, alternative hypothesis, the symbols that we are using. So if the question says, hey, analyze the difference between population proportions. In this case, first of all, you need to check the normality, then move on to form your null hypothesis, alternative hypothesis. Your null hypothesis says, hey, the first population proportion is equal to the second population proportion. An alternative hypothesis says they are not equal to each other. So this is the case that we have a two-tailed graph. Sometimes you read a question or a homework or an exam or a project and it says, hey, the first population proportion is larger than or equals to the second population proportion. So the alternative hypothesis becomes P1 is less than P2. And finally, you might have a case that the null hypothesis says P1 is less than equals to P2, or alternative hypothesis says P1 is larger than P2. Very good. So as you can see, after identifying your alpha, what is the level of significance? Alpha. We can find the critical values that help us to identify these red regions or rejection regions. After that, you need to find your test statistics, Z, which is equal to P1 hat minus P2 hat minus P1 minus P2 divided by the standard error, which is square root of P bar Q bar times 1 over N1 plus 1 over N2, and P bar is equal to, you're going to take the number of successes in sample 1. You're going to take the number of successes in sample 2 and divide it by the total number of values in these two samples. And Q bar is 1 minus P bar. Well, after constructing your Z, you're going to check to see if Z is inside the rejection area or not. So if Z is in the red area, our conclusion is that we reject null hypothesis, or if p-value is less than equals to alpha, you reject the null hypothesis. If not, we say that we fail to reject the null hypothesis, or again, if p-value is larger than alpha, we fail to reject the null hypothesis.